Hello everyone. This is the CAPD code workload. We are holding this meeting as part of the cluster API project, and this meeting is part of the should obey to the CNCF code of conduct. So please be kind with each other. And yeah, it is a code of conduct. It is a code workload. So please don't hesitate to ask questions and stop me. The agenda more or less is, first of all, understand the working principle of CAPD, so how it works. And then we will dig into some feature or some detail that are particular of CAPD, because CAPD is an infrastructure provider. So the job of CAPD is just to provide some infrastructure where a Kubernetes node run on it, but CAPD at the same time is not like the other infrastructure provider, because Docker is not a cloud. So inside CAPD, there are some things that were implemented in order to make it possible to work. So let's start. So I start sharing. So let me move these on another Windows, and then I share my desktop. So share desktop. Why I cannot share the desktop, but only a specific window? Oh, just a sec. I try to sort this out. Oh, it seems that it is not possible to share the desktop. I don't know why, but okay, let's work with what we have. So first of all, the working principle of CAPD. So when you use Docker, basically the working principle is quite simple. You use the Docker CLI, and you type Docker run, and basically the Docker CLI picks your command and forward to the Docker socket on the machine, and the Docker engine, which is listening for the socket, basically creates the container. And a nice way to think about CAPD is basically it is a controller that is doing the same for you. So the process is that a user uses kubectl and create a Docker machine. Then there is the CAPD controller that catches these the request to create a CAPD machine, and basically it forwards the request for you to the Docker client. Okay, and this is. And let's see how this is implemented in the code. So first of all, where it is cluster-ctl, it is under, where is CAPD? It is under test infrastructure Docker. Here we have, here it is implemented the Docker provider. And if we look, for instance, let's start looking at the Docker file. The first part is the build one. Let's focus on the last layer of the Docker. As we can see in the CAPD Docker images, there is the manager, so the CAPD controller, and then we have Docker. So this is the first signal that basically the CAPD manager is kind of interacting to the Docker CLI in instead of the users. One thing that is important for this is that in order to make basically this work, given that this is a container, it is required that the Docker socket is mounted in the container. And we can see this if we look at how we deploy CAPD, especially how we deploy the manager. We can see that basically the manager got a volume mount, which is the Docker socket from the machine. Okay. And also another point is that where we can see this is that if we pick at the package, there is this Docker package where basically most of the interaction with the Docker is implemented. And at the end, I got lucky and I got in the right position immediately. At the end, what CAPD does is to basically issue Docker command. This is this Docker run, and you see all the usual Docker parameters. So we're running a parameter with some flags and stuff like that. So trying to let me make this a little bit more clear. I have prepared the schema. Let's try to share this now. So where it is. Okay, this one. Let's make sure. And let's try to present this. So basically, this is what I was explaining. Docker run, talk, the Docker CLI talk with the Docker engine. Docker socket actually created the container. CAPD is similar, but in this case, the input is a user basically applying a CRD, which is the Docker machine. The manager gets understand that this Docker machine should be created. And basically, it talks with the Docker CLI, which is embedded into the CAPD image. And then it tries to create the actual container, but this is possible only if we get a volume mount inside the Docker container. And this is, let me say, the core functioning of this stuff. Usually things are a little bit more complicated because it happens that we use kind to run CAPD. That means that we are running CAPD, which is a container inside another container. And in order to solve this, basically what we need a kind mount, a kind volume mount, and probably you know that if you remember the instruction for the quick start in Cluster API, there is the instruction how to do this. And let me show you, and it is here. So you can create the kind volume mount. Okay, everything clear so far? Okay, thank you for the feedback. So, okay, let's move on and go back a second to the code. And we start picking, so we understood that CAPD generate container, and let's start to talk about a little bit how networking works. And you know, Docker networking has its own particularities. It works a little bit different in Linux than on Mac or on Windows. But basically, one thing which is important in Docker networking is that since the recently released Docker, basically you can put all your container into what is called a network, okay? And this was a change that was picked up by Kind recently and created a little bit of confusion. So let's try to clarify this. So first of all, now in the recent release and CAPD use the Kind network. So if we search for this variable, let me see where it is defined. So it will use the default network. Oh, sorry, I'm on branch. I have to switch my local things to master, git, checkout. Okay, so now it is the default network that CAPD uses is Kind. Okay, and this match basically the network that Kind itself is using. So when you are using CAPD inside Kind, everything is well aligned, and this does not create problem. Unfortunately, this was not the case until recently, because CAPD was deploying things in the bridge network, which was the one used before. And basically, there was this problem that CAPD was creating a machine on the bridge network, while Kind was starting from 0.8, was working on the Kind network, and this created a problem of the with the management cluster not being able to talk with the corresponding workload cluster. So try to make this clear, a little bit more clear. So share, where it is, this here. Share. What is the presentation? Okay. So, okay, next slide. So the problem is the following, and this was really a tricky problem that we had to solve, is that Cluster API basically requires that your management cluster should be able to talk with the with all the nodes, okay? But the problem was that if the management cluster was creating in Kind, basically Kind was setting network Kind for all the version greater than 0.8. And this was not aligned with CAPD that was creating a machine in the bridge network. And basically this was creating a lot of confusion for everyone developing with CAPD. And the only way that we got to get around this problem was to use this experimental environment variable, Kind experimental Docker network, and to force Kind to basically use the same network of the machine that we were creating. Now, luckily, we are on the same network. This is nice, but might be not all the developers are on the same page. This is described on our quick start guide on several points, but basically the problem of networking was complicated, and probably I hope that now is solved. And one of the things that I would like to discuss is basically the relation that there is between kind and CAPD, because often there is confusion. So in my mind, I usually think about this, so that CAPD and kind, they are loosely related, but they are not the same things. So, and I try to state some fact, and if you have more questions, please feel free to ask. So the first fact is that kind could be used to host CAPD, so to host a management cluster with CAPD. This is true, is what we usually do while testing, or we recommend in our cluster API guide, but this is not a requirement. So I can run CAPD on any Kubernetes cluster. I can use Minikube, K3S, or whatever. So this is a loose relation. The second point is that CAPD uses kind images for created containers. So when CAPD create a machine, if you look with Docker PS, you can see that the machine is basically use the kind-node image that is from kind. But again, this is not a strict requirement. Technically, we can use any image that satisfies kubeadmin requirements. So we can use any image that has a CRI and Kubernetes artifact installed in. And the last point is that, in fact, CAPD use also kind as a library, but to be honest, we are using only few utils from kind, and for all the most important part, we are basically working on with the Docker CLI for managing containers. So it will be also a nice activity to get this cleaned out.
Fabrizio, I had a question.
Yes, please.
On that first point about CAPD could run on any Kubernetes, is that, if you had Kubernetes running with just Cryo as the container engine instead of Docker, could you still run CAPD there?
No, the requirement is that you have to run somewhere where you can have a Docker socket mounted in. So basically, the host machine where you should offer you a Docker socket. This is the only real requirement.
Right. I didn't know if maybe Cryo or one of the other implementations. I didn't know if they implemented the Docker socket or something. So
no, because as you see in these Docker packages, we are doing Docker inspect, Docker exec, Docker PS, Docker run. So basically, the manager is a wrapper on top of Docker. Okay, this is not really where we want to be. In the future, we want to basically not shell out, but call or the Moby library or potentially a CRI library, so we can abstract this layer away. And also we are much more unit testable, which is something that is really difficult if you have a code like this. Like the one, like this is almost impossible to unit test this. And in fact, we are not unit testing. So, but yeah, as of now, CAPD basically shell out to Docker. and the Docker socket is a requirement.
Okay, yeah, that sounds like making it pluggable with some sort of, you know, CRI interface or something. Yeah, that would be amazing.
That would be amazing for many reasons. The most one, the one that I like is that we will have the chance to test CAPD itself much more easily, and then okay, it becomes pluggable.
Thanks, great explanation.
Okay, so let's dig a little bit into the code base. So, okay, Docker provider as an API, V1 Alpha 3, V1 Alpha 4, like other provider. Small note, we are not, given that we are treating this as a development tool, we don't have conversion in place between the two APIs like we have from the other provider. This is another nice to have things, and probably an easy one to achieve, given that the types are the same. So the conversion is no operation, is very simple to implement. Then we have controllers. So let's start taking a look at the Docker cluster and discuss how basically in CAPD we are creating the cluster infrastructure. That basically means how we are creating the load balancer. So first of all, quick note, CAPD at the end is quite simple. If you see that the cluster controller is 200 lines of code, so it is really simple. And if we look at basically the reconcile normal, it's simple. It uses this external load balancer object that basically what is it is a wrapper on Docker, and it call create a Docker that acts as a load balancer and give me the IP of this load balancer. And if we go down the code, so we see how this is implemented. At the end, the load balancer is nothing else that we are creating. This is a wrapper on the create method that we were looking before. So we are creating a container that uses a HA proxy. So basically, in order to do load balancing, we create a container which uses a HA proxy. Okay, this has some challenges because unfortunately, HA proxy does not support automatic discover of the control plane nodes. That means that every time a control plane nodes join our cluster, there are no automation that makes basically the load balancer made aware of the machine, like it happens, for instance, in AWS or stuff like that, where everything is related is driven by label or other rules. So one of the things that we see here is that we have a function that basically goes and updates the load balancer configuration inside the HA proxy. So at the end, this write file is nothing else than a Docker exec into the HA proxy load balancer that write a new configuration with the new machines, and then we are basically forcing the reload of the HA proxy configuration. Again, this is a trick to fake a cloud load balancer. It's not super ideal. Sometimes we see problem because we have the load balancer that restart in the middle of scale up, scale down. For instance, and it is also an area of improvement because now there are new load balancer that we can use that has out of discovery of Docker containers running. So if you think we can use Traffic, for instance, and it will auto discover the load balancer node without being forced to force the reload of the configuration. So this is another area, a difference from the other provider and a possible area of improvement. And just to complete this part, if we go on the Docker machine controller that is not much longer than the Docker, than the other, if you see where it is, after creating a machine, basically, if the machine is a control plane, so if the machine is a control plane, what we are doing, we are updating the configuration. So this is kind of weird because we have the machine controller that goes back to the load balancer and tells the load balancer, hey, I'm a new control plane here, please add me to the load balancing group. Okay, but it works. It is nice. So another thing that it is different from the other providers is how the actual bootstrap of the machine happens. Because if you think, for instance, again to AWS, what happens in Cluster API is that when a machine gets created, we are storing in the cloud in Cloud Init basically a script that runs kubadmin init or kubadmin join. And in Docker there is no Cloud Init, so this is technically not possible. So we cannot do init in the same way, but we want to work with CAPD. And so how this is implemented, I scroll a little bit down. Basically, it is implemented again. We are the CAPD machine controller take charge of acting like Cloud Init. So it reads the bootstrap data that usually goes to Cloud Init, and basically it is itself that runs the init sequence. So it is not a machine that runs the init sequence itself, it is the controller that runs the init sequence. And how this is implemented, we have this package here, which is Cloud Init. Inside this package, we have a really simple, basically Cloud Init parser. And this Cloud Init parser basically understand only two Cloud Init commands, which are run cmd and write files. And if you look at one of these, a part of the parsing of the Cloud Init, at the end, it translates the command into something that will be executed with Docker exec inside the machine. So it is kind of working the other way around, but we are solving something that was not possible otherwise. So let's try to, I prepared a schema also for this. So, okay, this one was about networking that we are registering and reloading. Okay, this one is the difference for between Kappa and CAPD for Bootstrap. So when we create a VM with Kappa or CAPV, we pass the Bootstrap data, and then it is Cloud Init that take charge of doing of transforming the machine into a Kubernetes node. In CAPD, instead, we don't have a Cloud Init, and basically what we do is we run Docker run to create the machine, and then immediately after we run a sequence of Docker exec that basically are a translation of the Cloud Init commands. we explored in the past the idea of putting Cloud Init on the container itself. It is technically possible, but it really requires someone with Docker black belt because it is really complicated to get a machine with Cloud Init installed. Does this make sense for you? Okay, so thank you. Okay, so this one was another difference between CAPD and the other provider. And there is, and if we go back to the machine controller, so, and we follow the sequence, so the sequence was, just to recap, okay, here we are waiting for the bootstrap data sequence like in any controller. Then if the Docker, so if the machine, in this case, the container does not exist, we are going to create it. Eventually, we are preloading images into the machine, which is something that speed up the Docker startup. Then there is the part of the, if the machine is a control plane machine, we are updating the configuration and we discussed why. We are updating some condition to surface that the things are progressing. And then there is the part of doing the bootstrap that we just discussed. Okay, the last bit is apart from, okay, reading some, getting the networking information and updating the status with the networking information is this one. So as you can see, basically, what we are doing here is that we are setting the node provider ID on the machine. And this is again something different from the other controller, because in the other, if you think for the other controller, there is a dedicated, for the other providers, there is a dedicated controller, which is the Cloud Controller Manager, or the CPI, that basically observe that the machine are being created and assign the provider ID on the node. Okay. Now for CAPD, we don't have a CAPD cloud provider interface implemented. That means that again, in order to make CAPD to act like any other provider, we were forced to implement this a little bit of code that goes and set the provider ID on the node being just created. It works. It created some problem, but now we have some retry, so it is pretty robust. What I don't like, it is different. It is again something different from the other provider. So I would really like that someone takes a little bit of time and implement a new controller that basically fakes a CPI, observe the nodes, and set the provider ID so we act like the other provider. Okay, so let's jump a little bit back on the presentation just to finish the notes. And so this basically is explaining what we just saw in Kappa. When a machine is created, a node is created, and there is the CPI controller that basically take care of setting the provider ID. In CAPD, we don't have such a controller, so it is CAPD itself that when the node gets created, it sets the provider ID, and this makes CAPD images basically to work and to fulfill the cluster API contract.
Could I ask a question there, Fabrizio?
Oh, sure.
So this idea you're talking about for the fake CPI controller, just I guess in the interest of anyone who might be listening and looking for stuff to work on, that would be another controller that would look for new nodes that join the CAPD cluster that don't have a provider ID set. Is that's essentially what it would be?
Yes. Yes, we can spec it out, but at the end it is what you're saying. If a node doesn't have provider ID, you have to assign a new one.
Right, a pretty simple controller, but it would only be used for CAPD, kind of like, like you said, it's the fake provider basically.
Yeah, the tricky part is that we have to basically to deploy this controller on the workload cluster that we are creating. So we have to use CRS or stuff like that.
Right, it has to act like some sort of fake cloud provider agent that isn't really there basically.
Yes, exactly. So the only problem, the part to figure out is not the implementation, which is really simple, but the deployment.
Right, makes sense. Thank you.
Okay, so moving on, another thing that it is a problem that we faced recently, and it's something that another possible room for improvement. So we have some providers that basically, when you create a machine, for instance, control plane one, you create a VM, and then you get the node, and it happens that the node has a different name that the machine node. Okay, this difference basically recently create a problem in KCP, if I remember well. SEDEF, you remember? Is there SEDEF? I saw SEDEF before.
Yes, so it was related to etcds were creating the problem because of the name difference.
Yes, because this node name, then for Kubernetes also the etcd name, and we had a problem because we are checking machine name against node name, and that they were different. So, and the fact that now instead we have CAPD that is simple. So when you create a machine, you got a name, and the node gets basically named with the same name. And this difference between CAPD and some of the provider basically prevent us to detect the problem early on the development life cycle. We detected in production, in fact, and this is not nice. So this is something really easy to achieve. We should change the CAPD in order that the node name is different than the machine name. So we are basically using with CAPD, we are reproducing this scenario, which is the most complex that the provider have. And yeah, and also talking about CAPD and possible idea for improvement. Recently with Mike, we discussed the possibility to add a resource limit for nodes, for CAPD nodes, because now every CAPD node basically gets unlimited, so it can consume everything it is on the machine. And another point that was discussed or raised up by someone is that probably we should and we can support restart, because restarting a CAPD, a node installed on a container, previously was not possible. Now the problem was fixed, has been fixed in kind, and given that we are we are really similar to kind in how we create the node. So the Docker exec command that CAPD is executing is really similar to the one used by kind, and we are using the same kind image. Probably it is possible and easy to make a CAPD machine to be able to restart, and this is something that could be interesting to implement. And the last bit of the last point that I would like to remind, and I go back to the code base. So if there are questions, I can answer there. Is that it will be really nice to decouple CAPD from Docker exec, so we can implement some serious unit test of CAPD itself without which now is not possible because everything basically shell out and requires the Docker socket. And yeah, this is what I wanted to show. I don't know if there are some questions. I see Raja with the hands on. Please speak. Feel free to speak without raising it.
Oh, okay. Yeah. First of all, thanks a lot for the walkthrough. It has been very helpful. You were mentioning that there was a problem when the machine and node name were same for some of the providers. And actually, I didn't quite understand what the problem was. So do you mind going over that again?
Oh, yeah. So the problem was not in CAPD itself. It was in the control plane controller. And it was in the remediation part, Sedef. Do you remember?
Not the exact location.
Okay, but probably it was in the remediation because in the remediation, in KCP remediation, basically we are comparing the list of nodes of etcd members and the list of we are trying to figure out if there was unknown etcd members, and we were using the machine name instead of the node name, and basically all the nodes this was not working because we were comparing control plane 1 with IP whatever, and it was saying you don't have this this machine does not have a node, an etcd member, and so the test was failing. I don't remember exactly the test where the test was
210.
Yeah, exactly. So basically we were doing this test, and before we were doing, instead of comparing the node name, we were comparing simply machine.name. And this test was failing, was passing with CAPD, but not passing with Kappa.
I just added the fix link on the chat.
Oh, thank you very much.
Okay.
Yeah.
Thanks.
Yeah, but the point is that I think that the point behind this issue is that we are using CAPD to test CAPI, and we have to make sure that CAPD mimics as much as possible real provider, so our tests are more reliable. Some other questions or things that people would like to ask? Another thing that I got asked recently is about CAPD and basically the space of disk being consumed. This is not really a problem of CAPD. It is a problem of Docker. But with CAPD, if you test a lot with CAPD, the problem is somehow annoying, because basically CAPD is using the kind image, and the kind image itself is 1 gigabyte. And basically, if you create and destroy machine, the Docker, the space, the disk space of Docker get full quickly, and so you have to often run Docker system purge to remove to free the disk space. Otherwise, you get a wave error. This is another point. So when it happens, basically we don't get meaningful errors back from Docker, and probably the errors are also masked by the fact that we are shelling out, so we don't have a real return value back, and this is really difficult to debug, and yeah, this is something that people using CAPD should be aware of. And the other part is that, okay, we are using CAPD for the cluster API end-to-end test. Since some time ago, until some time ago, it was possible to run the entire end-to-end test, because there was 5 of 6 tests. Now we have much more, and they are even more, they are also more complex. And so if you try to run the entire end-to-end test locally, you get two kind of problem. First of all, is resource consumption, because we are running a lot of tests and in parallel, and at the end you might hit the problem of disk space if you do this 2 or 3 times. So my suggestion is to run, when you test locally, end-to-end test is to run only one end-to-end at time, and use Ginkgo Focus to do so. Some questions?
Luigi, I don't know if you have enough time for this, but would you be able to show how do you like debug E2E tests, like in VS Code? I don't know if you're using VS Code.
So end-to-end the problem of end-to-end test is that the goal of the end-to-end test is to basically run a test on a real infrastructure, and or something that mimics a real infrastructure. And for running end-to-end test, we are not only using an infrastructure, but we are also building and using our CAPI images. And given the fact that we are running CAPI images, it is not possible to basically debug. So put a breakpoint and get a code. You have to rely on the logs, and we have. And if you run an end-to-end test, we have probably have an end-to-end test here run. What we are doing is that we are capturing a lot of information from the end-to-end test. So we are capturing logs from all the controllers. So you have the logs and you can check them. We are capturing all the resources that we are going to create, so you can look at Docker machine, stuff like that. And by the way, the same information are also available in our test grid for each test. So basically, the answer is that debugging and end-to-end is not possible. You have to look at the log and try to solve the problem. What I'm doing is instead of running, when I have a problem, and I understand where the problem is. Then I use tilt. So I use tilt up to create things that I can much more easily debug, add logs line where I need, and I mimics the problem there. So by mimics the problem, I have also much more control in executing the step before the problem and the step that creates the problem. So I don't recommend to debug end-to-end test. I recommend to use tilt and reproduce the problem step by step. Does this make sense for you?
Yep, that does.
Thank you.
Thanks, Fabrizio.
Okay, we are 5 minutes, a few minutes late at the end. So if there are no more questions, we can stop there. I will share the slides in Slack. But if you have any question or you are interested in anything regarding CAPD, feel free to reach out to me or some other maintainers.
And I will upload this to YouTube as soon as it gets finished processing, and I'll put the link in Slack for everyone.
Thank you very much, Mike. And thank you everyone for participating.
Thank you, Fabrizio. This has been amazing.
Thank you. This is great.
Thank you, Fabrizio. It's great.
Bye-bye.
Bye, everyone.